Right, this is question 5. State what is meant by the spring constant. The spring constant is essentially defined by Hooke's law here, F equals kx. A quick rearrange tells me that k is equal to F over x. So therefore the spring constant is the force per unit length. And so that should be all we need for our mark. Show that the unit of k may be written as kilograms seconds minus 2. So given that it is force divided by extension and F equals ma, we can write that k is equal to ma over extension. So the units of k must be equal to the units of mass times the units of acceleration, meters per second squared, divided by the units of extension, meters, which is equal to kilograms seconds minus 2. So some experimental results here. Important thing to note that it is the length of the spring that is listed, not the extension. So if we plot that on a graph, force length, it looks like this. It has it doesn't intercept at 0, 0. It still has some length with no force applied. So the gradient of this graph is still k. So we can still find k by taking the change in y and dividing by the change in x. Simple as that. So 5 minus 1 divided by 0.45 minus 0.25. What does that equal? 4 over 0.2, which is 20. Newtons per meter. State any assumptions that we've made. Well, we're assuming that the spring obeys Hooke's law and produces a straight line graph. So okay. Determine the unstretched length of the spring. Show your reasoning. So if k is 20, then 1 Newton force causes extension x equal to F over k equals 1 over 20 equals 0.05, and the spring is 0.25 meters with a 1 Newton force. So the unstretched length, unstretched equals 0.2 meters. Because I'm just subtracting this 0.05 from 0.25. And I think, I've explained that reasonably. So show your reasoning. There's only 2 marks to be had here. One is going to be for this answer and one for the reasoning. I think that's reasonably well explained. Calculate the elastic potential energy stored in the spring when the weight is 5 newtons. So with the 5 Newton weight, the extension of the spring is equal to 0.45 minus the unstretched length 0.2 equals 0.25 meters, and elastic potential energy stored is a half times force times extension, or you could put a half of kx squared. It doesn't matter, you'll get the same answer. So a half multiplied by 5 multiplied by 0.25. So that gives me, what does that give me? 2.5 times 0.25 is 0.625, I think, joules. Arguably, I should give that to 2 significant figures since everything else is, and say 0.63 joules. And just to check, a half kx squared would give me the same amount. A half times k is 20. So half times 20 would give me 10, and x squared, x we've said is 0.25, 0.25 squared is 0.0625, multiplied by 10 would give me 0.625 joules. Yeah, question 5 done.